The court suspend the two buckets in equilibrium as shown. Determine the weight of bucket B when bucket A has a weight of 60 pounds. So we are finding the weight of B, bucket B. For this one, we are going to actually need to work through two different free body diagrams. So I'm going to start down here in this corner and draw the first free body diagram of F. We have our tension coming up here, T of force or between F and C. And then up here we have our tension, call it EF because it's between E and F. And we have a weight coming down of 60 pounds. So doing the equations of equilibrium for this free body diagram first, we do the sum of the forces in the x direction. Oh, we should label our angles 20 degrees and 40 degrees. So TFC times the cosine of 20 degrees minus TEF times cosine of 40 degrees is equal to 0, is all of my x components. I'm going to go ahead and solve for TFC to make it easy. So I have TFC cosine of 20 equals TEF cosine of 40. And then solving for TFC, I have TEF cosine of 40 over cosine of 20. I'm going to call that equation 1. So then I can do the sum of my forces in the y direction. I have negative 60 pounds plus TFC sine of 20. The y component of TFC is up, and then the y component of TEF is the sine of 40 degrees, and that's equal to 0. So solving for stuff, I'm going to do, what am I going to do here? I'm going to go TFC, I'm moving the 60 pounds over to the right. TFC sine of 20 degrees plus TEF sine of 40 degrees is equal to 60. So I have TFC. I'm sticking now this. No, sorry. I'm going to stick TFC from equation 1 into this TFC. So I get TEF cosine of 40 over cosine of 20 times the sine of 20 plus TEF sine of 40 is equal to 60. So then I have 0.27 TEF plus 0.64 TEF is equal to 60. 0.91 TEF is equal to 60, and so TEF is 65.9 pounds. And if I sub that into equation 1, I get TFC is 65.9 times cosine of 40 over cosine of 20, and TFC is equal to 53.75 pounds. So those are two interim values that I need to be able to solve this. Now my second free body diagram is going to be at point C. So we have TCD here with a known angle of 65 degrees. We have our weight B, which is what we are looking for. And we have TFC at an angle of 20 degrees. It's important that we recognize that this TFC from this free body diagram, we'll call it free body diagram at C. So TFC from our free body diagram at C is the same as the TFC from our free body diagram from around F, point F. So it's really important, otherwise we can't solve this, to recognize that those are the same. They're the same rope, so they're going to have the same force applied to them. Here now, if we do our equations of equilibrium, the sum of the forces in the x direction, we're going to just sub right in there and make this 53.75 because we found that in our last set of equations. So TFC there is negative 53.75 times the cosine of 20, so that's the component of TFC, plus TCD times cosine of 65 degrees is equal to 0. So the only unknown we have here is TCD. We can just go ahead and solve for that. So TCD cosine of 65 is equal to the scalar of 53.75 times cosine 20. So 50.5, and then TCD then is equal to 119.5 pounds. And then finally, we can do our last equation, Fy, and get negative WB, that's the weight going down, minus the y component of the TFC, which is negative 53.75 times the sine of 20 degrees, and then the y component of TCD, and it's positive, and I'm just going to go ahead and stick TCD right in there since I already found that, times the sine of 65 degrees is equal to 0. So this is a scalar, this is a scalar. I can just solve for my WB. Negative WB minus 18.38 plus 108 is equal to 0. So WB is equal to 89.62 pounds.